Hey Geometry, here's something new for you. I'm going to go ahead and do my key and let you go ahead and review for your quiz before you have to take it. Pretty cool concept, right? All right. Describe Euclid's role in creating the geometry we study. So this is a thinking question. So I want you to pause the video and I want you to add your thoughts in the bubble. Here's my answers. So what Euclid did was he organized work that already existed before him. He simplified everyone's very academic, language-filled ideas, and then he came up with precise definitions that he used as the building blocks. So the kids always ask me first, is this going to be on the test? Well, yeah, because I'm going to ask you this very question, and I want you to tell me about Euclid's role. If we're studying Euclidean geometry, don't you think it's important that we know who the dude is that started it all? So will you have to know who Euclid is? Yes. Okay. So this diagram here talks about, for all the questions for 2 through 7. So when we talk about non-collinear points, we're talking about points that are not a part of the same line. Now there's more than one answer here. So anytime that you talk about any 3 points, you have a right answer because all of these line segments are made up of just 2 points. So if I talk about 3 points, A and B and D. Now here's what you have to have correct. You have to know that points are capital letters. You have to know they're separated by commas. So the notation is as important as what it is that you're talking about. Okay, name a point in the diagram that is coplanar with A and D and E. Let's check out where these points are. So coplanar, if I have A and D and E, we're talking about this face of my rectangular prism, so that answer would have to be H, and that's the only right answer. So for here, where we have many correct answers, here we have just one correct answer that's on this page. Okay, name a point in the diagram that is coplanar. So go ahead and grab a new color with G and H and B. So this is a tricky one, and the kids that do this homework and listen to this video are going to get this one right on the quiz, because what we need to recognize is that G and H and B are all part of a plane that we can't see. But once I draw it, you can see that there is this diagonal plane that cuts through the interior of this rectangular prism. So again, our only coplanar point with G and H and B, that's right, is going to be A. And guess what? This is the only correct answer that we're going to accept for this one. If you're here listening to the video, you just got a point right on the quiz that your other friends that don't watch the video are going to miss out on. Good for you for being here. All right, name 2 line segments that intersect at point F. So when I'm looking at F here, I have this line segment here. Now I've got a choice. I can talk about FG, I can talk about FE, but don't forget about FB. So when we talk about 2, we could actually say 3. They only asked us for 2. So FE and FG also intersect, but you could list also FB. Don't forget, when you're talking about a line segment, you absolutely have to include this symbol because that's what means that line segment. Okay. Name 2 planes that intersect at point CG. So when we talk about point CG or at line CG is going to be down here. So here's line CG. So if we're talking about planes that intersect, if we talk about this one here, that's this side of my rectangular prism, and then we'll see if we can get another color going on. This back face of this prism also intersects. So when we name two planes, we need to make sure that we talk about it in terms of 3 points to name a plane. So I can say that plane BCG and plane, we can say planes BCG and DCG. So if you throw in that fourth point, you risk getting the answer wrong, because when you name planes, they have to be in a ring around the rosy order. So if you list this point, let's say you do DCHG, you'd get it wrong. So we need to make sure that you do them in ring around the rosy order, so you can eliminate that risk by just using 3 points to name your planes. Planes BCG and DCG intersect at line CG. Okay, name 3 rays with point D as my initial point. Here's point D, so we can talk about ray DC, we can talk about ray DA, and we can talk about ray DH. Each of those rays has point D as that initial point. All right. So for this next section, we're going to be talking about this shape here. It's a triangular prism. It's a prism because it has rectangular sides, parallel congruent bases that are a polygon. So that's a peekaboo as far as what we're talking about as far as our 3D shapes. We're not going to get to that to the spring. Okay, let's talk about A, D, and F. Are A and D and F coplanar? Sure they are. Do you see this plane here? This side of the tent, if you want to think about that triangular prism as a tent. Are they coplanar? Yes. Okay, so now we're going to talk about line AC, this line here that goes through A and C, and line FE. Are those coplanar? No. So those are not in the same plane, so we're going to say no, and in fact, we would call them skew lines. How about A and B and E? So if I talk about A and B and E, sure, that's this side of my tent. So can we talk about those being coplanar? Yes, they are. All right, so now I have D and A and B and E. Guess what? Those are also going to be coplanar because we have, notice A, B, and E and A, B, and E. Now we're just including that fourth point D. So yes, that's still going to be a coplanar. A and C are collinear. Yes, I guess it should be writing true instead of yes or no. D and E and B are collinear? No. So that is going to be false. If you want to go back to the true and the true, this is false, and this is true. Okay. How many sets of 4 collinear points are there in this 4x4 grid? I want to pause the video, and I want you to think about it, and then come back. So what did you get? I ended up with 10. Don't forget we have to have 4 collinear points. It'd be interesting to see how our answer would change if we went from 4 to 3. Because just imagine how many more I could have with 3. We'll stick with 4 for next. Okay, let's talk about this next one. Line segment A, B, and CD do not intersect, but line DC intersects line segment AB in 1 point. Make a sketch that shows this. Pause the video and see what you think. So here's what I came up with. Line segment DC and AB do not intersect. That's a true statement. But if we call this ray DC, it will eventually, because it continues on forever, intersect in 1 point. All right, let's see what's going on the back side. So if it's talking about finding QR, that's going to be the distance from Q to R. So this is what we're looking for here. We can write a simple equation thanks to the segment addition postulate. 35 plus x is going to be equal to 60. Oops, don't need two equal signs. So then therefore our x is going to be equal to 25. When we're talking about distance, we always want to put our units. If they don't tell us inches or centimeters, then that's fine. We can just say that the distance from Q to R is 25 units. All right, so let's see, find the distance from J to L. So our segment addition postulate says if that's x, then I know that, and k is between, then I know 19 plus 48 is going to be equal to x. So therefore, x is equal to, what's that, 67 units. So we can add a little units down there. All right, is it possible that the distance from P to Q plus the distance from Q to R is smaller than the distance from P to R? So here we have a picture involving P, Q, and R. But nobody ever said that we're supposed to use this diagram, and nobody ever said that Q is in between. So let's draw a couple scenarios. Let's say that I had P and Q and R in this order, but what if I had Q and P and R? Okay, what if I had P and R and Q? So take a minute and look at each of these three possibilities and see if any of them shows that this is either true or not true. Go ahead. All right, so I'm thinking not, because if I have PQ plus QR, that's going to be equal to PR, so not less than. If I have PQ and QR, that's not going to be less than. That, in fact, is going to be greater than. And if I have PQ plus QR, then that, again, is going to be greater than. So we're going to stick with this answer of, is that ever possible? No, it's not. All right. In the next one, if the distance from E to D is 5y plus 6, and the distance from D to B is y plus 30, find that value of y. So we've got two steps here, and I want to make sure that you're smart about how you do this, because number one, you have to find the value of y, and then don't forget to answer these questions, because we need to make sure that we finish what we start. All right, so let's see. ED, this distance from here to here, is going to be 5y plus 6. This distance from D to B is going to be y plus 30. So here's the thing. These hash marks guarantee that each of these segments is the same distance. So I can set them equal to each other and solve for y. 5y plus 6 is going to be equal to y plus 30. Subtract 1y from each side, subtract 6 from each side, and I end up with y has a value of 6. So because y has a value of 6, this is now what I have to substitute in to find the distance from E to D. So ED is going to be equal to 36, which means that DB is also 36, and the distance from E to B is going to be double that, so it's going to be 72 units. So units, units, units. All right, so you take a look at 14, come back and check your answers with me. All right. So same story, each of these are equal to each other. So my 6x and my 4x plus 18 are going to be set equal to each other. and then I do some simple algebra, and I get x is equal to 9. And then I substitute back in to find those distances. Because these are numerical values, they are equal. That is going to be that measure of that line segment. All right, one more. Go ahead, put the video on pause and make sure that you have solved this. All right, so this one's a little trickier. And remember, whenever we have these values, they replace what was before. So I know we said that ED was 5y plus 6, but once we enter the new part of the problem, we're going to go with that new expression to represent. So let's think about the orange values instead. So this whole distance from EB is 4y minus 12. So I know that this plus this, or 2 of these ED segments, that's why I have to make sure that I multiply my y plus 17 times 2. Simple algebra gets me a y value of 23. And then when I substitute those values back in, I get 40 units for each of the 2 little segments, and then 80 units for the larger. All right, so in section 1-3, that's when we started talking about angles and angle measures. Well, that's actually 1-4. So here we are in 1-3, again, looking at our segment addition postulates. So go ahead and make sure you solve 16 and 17 and come back and check your answers. All right, so in number 16, notice we want to make sure we read carefully and we answer what they asked us. They just want to know what x is equal to. So I set those 2 congruent segments. I set their measures equal to each other, and I can solve for x, and that's all I needed to do. Circle my answer, and I'm good to go. In number 17, I've got the value of x is equal to 4, but that's not what they asked. They asked for the distance from A to F, so I can be sure to give that to them. AF, the distance from A to F is going to be 8 units, and here's my final answer. All right, so here in 1-4, we get to talking about angles, and they asked us to name this angle in 3 different ways. So I can say that that's angle JKL. I can say that that's angle LKJ, or I can say that that's angle K. Either way, K is going to be my vertex, and that's the letter that always has to be at the center. The only reason I can do this last version here is because there's no other adjacent angles. So for example, if I looked over here, I couldn't call any of these angles C because you wouldn't know which one you were talking about. Okay, so let's take a look at number 19. Using the angle addition postulate to find the measure of the angle. So remember, whenever we're talking about the measure of an angle, that's where I go ahead with this M out in front, and that lets me know I'm looking for a numerical value. So the measure of angle ABC is going to be the measure of these 2 angles added together. So ABC is going to be 130 degrees. Please make sure anytime you're talking about a degree measure, you have to include the units so we know what you're talking about. Okay, so when we look at the measure of HLK, this box here is super important. It lets us know that that is a right angle and it's 90 degrees, which means these 2 angles are complementary. So if the measure of the angle KLJ is 30, I know that the measure of HLK is going to be 60 degrees, and then my whole angle is a right angle, and that's going to be 90 degrees. All right, let's talk about 1-5. Given that S is a complement, okay, and so here we have some conversations in what does it mean to be a complement or a supplement. So let's take a look at this. When we talk about a complement and a supplement, remember when we have a complement, that is for a 90 degree sum of the measures of the 2 angles. If I have a supplement, my S for supplement, that means that those two angles are going to then add to 180 degrees. So we have to think about this S for the supplement and this C for the complement. Okay, so given that S is a complement of T, that means that S and T added together are going to equal 90 degrees. So once I find out that S has a measure of, and that degree symbol's there, it's just real light. So 32 plus some value has to equal 90 degrees. So when we're talking about what we get there, sounds like a 58 degree measure. So we'll go ahead and think about that for a minute, make sure I did my math right. So that means that the measure of angle T is equal to 58 degrees. So when we talk about U and V, if I know that the measure of angle U is 27 degrees, I know that 27 plus whatever I'm looking for has to equal 180. So then I know that my X value is equal to 180 minus 27, which sounds like 153 degrees. And let me put this here. So that then I know that the measure of angle V is equal to 153 degrees. All right, last one. Ray RT is the angle bisector of QRS. Given that the measure of QRS is 90 degrees, what are the measures of this? Okay, so they want us to sketch it. So I know right here that QRS is 90 degrees, so I'll go ahead and draw what looks like a 90 degree angle. And I have QRS, we'll call this Q. I know R is my vertex because it's the middle point. So when I draw RT, which is our angle bisector, it tells me that it divides it evenly. So we can call this X, and we can also call this X. So I know that X plus X has to equal 90 degrees. So 2x is equal to 90 degrees, so x is equal to 45 degrees. So what are the measures of QRT and TRS? Both angles measure 45 degrees. So the measure of angle QRT is 45 degrees, and the measure of angle TRS is equal to 45 degrees. All right. So if this was not a difficult task for you, I think you're ready for the quiz. Good job.